Hello again. In this video, we're going to talk about limits as x approaches infinity. And if we know the graph has a horizontal asymptote, this is very easy for us to determine. So for a second, let's take a minute and consider what a horizontal asymptote means to a graph. So we may have some graph with two horizontal asymptotes. And maybe the graph looks like this. This is my rational function here. All right, so suppose this horizontal asymptote is at, say, x equals positive 3. Now, if we think about what asymptotic behavior is, that means the function is approaching that asymptote forever, but never actually touching it. All right? So it is getting infinitely closer, and as we move out this way, out to the right, approaching that asymptote, it gets closer and closer and closer and closer and closer forever, and that gap gets smaller, but technically it never ever touches it. If we're to take that logic and I say, well, what is the limit of this function as x approaches positive infinity? Well, x approaching positive infinity, that means as we go this way forever on the graph, where does my y value tend toward? And my y value is going to approach that horizontal asymptote. So in this case, it would be 3. So let me erase this and we'll write kind of a more formal rule. If a rational function has a horizontal asymptote, so we'll say that f of x has a horizontal asymptote at y equals b. All right? Then the limit as x approaches positive infinity for that function would equal b, and then the same, the limit as x approaches negative infinity for that function would equal b. So if we know the horizontal asymptote of a rational function, then the limit as x becomes infinitely large in the positive or negative direction, that limit is always going to equal the value of the asymptote, because we're going to be getting slowly and slowly closer and closer to that asymptote. We're coming up and we're approaching it forever, whether it's from the top or the bottom, right, as we just did. But it's approaching it forever, and it's never going to touch that asymptote, the horizontal asymptote. And the same goes for going in the negative direction. As we go towards negative infinity, it's going to get infinitely closer to that, but say never ever touch it. All right, so let's just look at two quick examples. In this example, we're given a function, 3x squared plus 15 divided by the quantity 17x squared plus 2. And we're asked to find the limit of this function as x approaches both positive infinity and then part B, negative infinity. So what we know, looking at this function, is that we will have a horizontal asymptote. My horizontal asymptote is going to be at y equals 3/17. So that would mean the limit as x approaches positive infinity and negative infinity for this function, both of my answers would be 3/17. It's always going to be the value of that horizontal asymptote if we are looking at the limit of a rational function approaching either positive infinity or negative infinity. Let's do one more example. So here we have the limit of a rational function. We have limit as x approaches negative infinity of 3x to the 15th plus 17x squared divided by 2x to the 40th minus 5. Now, this is an entire rational function. And earlier in this unit, we learned that we take the number and we try to plug it in, right? But this is not a polynomial. And thinking about infinity, is infinity a quantifiable amount? And it's not. We don't know what infinity is. So we can't perform a calculation with infinity because it is not a number, or even negative infinity in this situation. So we can't plug it in and evaluate it. But what we do know is that since the degree of the numerator is 15 and the degree of the denominator is 40, and because the degree of the numerator n is less than the degree of the denominator d, what we know is the horizontal asymptote occurs at y equals 0. So that means to answer this question, my answer, the limit as x approaches negative infinity, and it would be the same for positive infinity, is 0. All right, so in some future videos, we're going to look at what happens when we do not know that horizontal asymptote and other more algebraic strategies that we can use.